to this course on reefer container operations. This course is designed to enable you to give an overview of the regulatory and legislative controls relating to reefer containers, describe the history of reefer containers, describe modern reefer containers, give an overview of reefer container construction and design, describe the packing arrangement of reefer containers, explain what information is required for shipping reefer containers, give an overview of special shipments, describe the pre-acceptance checks, explain how reefer containers should be stowed on board, describe how reefer containers are monitored at sea, give an overview of how issues relating to reefer containers are resolved at sea, explain how dangerous goods cargo is handled, and give an overview of the discharge process for reefer containers. At the end of this course, there is an assessment. These questions are assessed and have a 70% pass mark, so please pay close attention and think carefully about your answers. Under the Safety of Life at Sea Convention, cargo units, including containers, vehicles, and other movable entities, should be secured on board the ship as per the Cargo Securing Manual, CSM. The CSM was approved by the administration and drawn up to a standard at least equivalent to the relevant guidelines of the International Maritime Organization publication, the Code of Safe Practice for Cargo Stowage and Securing. In accordance with the International Safety Management Code, each ship should have a procedures manual that details how to safely handle, stow and secure the cargo, including maintenance of equipment, such as reefer plugs and emergency procedures for any fires, pollution or risks from cargo. The International Maritime Dangerous Goods Code is a detailed set of requirements produced by the IMO covering the transport of packaged dangerous goods by sea. It ensures goods are clearly identifiable, segregated, packaged and transported correctly, and have emergency procedures in case of spillages, fire and medical incidents. Delegates on this course should make themselves familiar with all company procedures and operating manuals for carriage, operation, repairs, breakdown, reporting and spares pertaining to the ships and reefer carried. Over 200 million containers are shipped all over the world every day. Not all products shipped are resistant to external factors on long-distance journeys. For example, fresh food and medicines need specialized containers to avoid perishing. These containers are called reefers. The term reefer applies to a transportation unit which is used to move durable and non-durable items in a refrigerated or frozen state. Generally, refrigerated cargo ships or units are called reefer ships or reefer containers, though reefer containers are most commonly called reefers. A reefer has its own refrigeration unit, but will require external power through electrical power points called reefer points, from a land-based site, a ship or at the quay. During road, rail or trailer transportation, reefers can be powered by transport units or diesel generators. However, it has not always been easy to transport meat and vegetables. In the early 19th century, ships would use packing ice and salt to ensure that items did not spoil, but it was a difficult task, having to cut ice from frozen lakes in cold areas. As more engineers took an interest in experimenting with long-distance refrigeration and technologies advanced, by the 1960s, insulated container ships were fully developed and cargo units were being shipped worldwide in a standard size that could travel by road or rail. In the 1960s, specialized ships with an internal refrigeration plant were used with controlled air, Conair containers stowed under deck so they could be hooked up to the controlled air system. The air within the container was temperature controlled and pumped in through the bottom porthole, circulated around the cargo and then returned via the top porthole for hot air to vent and be recycled again. Back then, it was possible to ship and maintain the air in over 1,000 units. A designated refrigeration engineer or a frosty would look after the plant and monitor the cargo. An advantage of the reefer over an open hold was that a loaded reefer set at -20 degrees Celsius would take almost a week before there were any signs of risk to the contents inside, regardless of the outside temperature, as long as the doors and/or portholes remained closed. Trying to keep an open cargo hold sealed and cooled with a large amount of cargo would perish much quicker. On the other hand, there were also some disadvantages with Conair containers. For example, road and rail transport could be difficult as the containers were unable to hook up to a power system like they could on a ship. Generally, refrigeration machinery would be added on, which was cumbersome and would stick out from the container. The air could not be controlled for each individual container, only in the single stack under deck, which would usually include 8 to 10 containers. Care had to be taken to couple and uncouple the containers correctly to the holes. In some cases, port operators would mistakenly cause damage by not realizing they were still connected before trying to let them out, and only 20-foot units were available, which meant limited cargo space for shippers and a higher logistics cost. By the 1970s, refrigerated containers were built with integrated cooling systems, which were called integral containers or integs, and are still used today. Each unit is operated by electricity that is supplied via a socket from the vessel or vehicle. Some have an electric diesel generator as a backup system to protect the contents from perishing in the event of power loss. Integs also don't have strict hookup dimensions like the Conair containers, only access points on the transport unit in order to run a cable and plug them in. To carry a large number of integs, ships must have the electric generator capability to handle all the units. Only a few hundred could be carried, though on modern ships, over 2,000 containers can be transported, on deck as well as under deck. Disadvantages of integs include: each unit has its own individual refrigeration plant and machinery, which can increase problems as there are numerous plants on board. Each unit must have safe access for plugging and unplugging, monitoring and repairs. The machinery and fans can be loud when running. Integs discharge air and heat. This means that a system of fans and vents is required under the deck to release the air and heat, which can be a hazard. And large power plants are required on board ships to cope with the number of integs carried, which takes up space, is more costly to install and maintain, consumes more fuel, and therefore increases emissions. Reefer containers differ from standard containers and are more expensive to produce and maintain. Let's take a look at the construction and design of a reefer container. The polyurethane insulation is 10 to 12 centimeters thick. The temperatures are adjustable between 25 degrees Celsius and -25 degrees Celsius, though some newer types can be set between 35 degrees Celsius and -60 degrees Celsius. Each unit has a T-grating aluminium floor with an air duct to allow airflow underneath the cargo and has a stainless steel food-grade interior lining. The power connection is 380 to 440 volts or 32 amperes. The outside color of the container is white to reflect any heat from exterior sources. The containers can be driven by a lift truck or forklift, and the containers have insulated doors and are wind and waterproof to protect from outside conditions. Along with identification markings, the container will carry a plate or label indicating the date of manufacture, dimensions, weight and height capacity, and stacking abilities. Also shown is how the container is monitored under the International Convention for Safe Containers and the approved Continuous Examination Program. This ensures the container is always fit for transporting goods and its integrity is maintained to international safety regulations. The container door security lock seals should be intact on arrival at the final destination. The ship's crew have no involvement in packing the containers. This is done by the shipper of the cargo or their representatives. When packing, there must be no large gaps between the cargo and the walls or other pieces of cargo. The cargo should be stowed in blocks where possible or secured inside. This will help to ensure that the cargo does not move whilst on passage. Air must flow through the cargo at all times to remove heat and gases to ensure a chilled temperature. Therefore, the transport boxes used should have ventilation. Fresh air ventilation is required for fruits and vegetables, and for frozen goods, air must flow around the cargo at all times. The ship must be given all the important information about the reefers before loading to ensure that the units are loaded into the correct positions to hook up to power and to provide safe access, and so that empty reefers that don't require power are placed in the right location on board. As well as the usual loading information for each container, the reefer manifest will be passed on to the ship's crew. The manifest will include important information such as the stowage position, what the container is holding, the set point temperature, information on ventilation, the level of humidity required, and information on how to ripen on the voyage. Special shipments or high-value reefer cargo must be monitored and maintained on board with greater attention. For example, Häagen-Dazs ice cream can be worth millions of pounds per container, and therefore a loss or damage to such cargo could result in huge insurance claims. These types of special shipments require special containers. For example, superfreezers that chill from -60 degrees Celsius to -10 degrees Celsius. Controlled atmosphere containers, which allow temperature, humidity and circulation control, and cold treatment containers that keep fruit and vegetables in a healthy state. These containers are generally stowed in specific locations on board for ease of access and removal, if need be. Monitoring and repairing must always be possible by a trained on-board technician. Specific spares and equipment must be always available on board. Once a reefer container is loaded on board, it should be visually checked. Then it should be plugged into electrical power immediately, especially if the contents should be chilled and the loading port has a hot climate. Visual checks should include the following as a minimum. Does the container identification match the manifest, and has it been loaded into the correct position with a plug socket available? If on deck, is it secured by the twist locks accordingly? Is there any serious structural damage to the container which may impair the insulation and should be reported? Are the doors, sides and seals intact? Are there any leakages, condensation or strange smells coming from the doors or the refrigeration unit? Is the cable and plug in good condition? After plugging into electrical power, do any alarms come up? Does the temperature setting match the manifest? A good sign is that the compressor starts cooling the cargo down. Keep a close ear on any strange noises that may come from the refrigeration unit which may be of concern. If so, the ship's crew should report to the necessary port contact. Check the ventilation and dehumidification settings and check the controlled atmosphere and cold treatment settings if applicable. Whilst in port, if there are any concerns with reefer containers, this should be reported to the necessary port contact immediately so that a reefer engineer can inspect. If this cannot be done, the container should be removed in order to be repaired on shore. If sufficient time is available, the cargo may be transferred to a functioning container before being loaded on board again. Every ship will have a reefer plan showing the positions the reefers should be loaded in, location and number of plug sockets available, and location of safe access to the reefer. Generally, the reefers are loaded on board with the refrigeration machinery facing aft or towards the back of the ship. This ensures an extra level of protection from the sea and weather, which generally comes from ahead. It also allows any water or condensation to run aft, as this is where the ship drains and bilges are located. The reefers are never loaded to the furthest port or starboard point on deck, as this is too near the ship's side, and therefore puts anyone plugging or unplugging, monitoring or repairing the reefers at risk of falling over the side. On roll-on, roll-off ro-ro ships, the containers will sit on a lorry but are plugged into the ship supply whilst the ship is at sea. Reefer containers can be used to carry dangerous goods under strict conditions. Due to the heat given off by the reefer motors, other containers with dangerous goods inside should not be stored nearby. The heat from the motor could increase the risk of fire, which could result in an even greater risk if it should affect the dangerous good inside. If there are two containers with dangerous goods inside that may pose a problem if they were to interact, the containers must be stowed at a suitable distance from each other, as per the International Maritime Dangerous Goods Code. This does not apply to empty reefers, as the motors would not be running. Once at sea, the reefer will always be connected to the ship's electrical power and will be continuously monitored by technology via an onboard computer, including alarm presets to warn of any issues. For example, if the supply or return temperatures were to get out of range on the reefer panel. Most operators have a remote container management (RCM) system, which is a constant monitoring system on board. The RCM can be monitored from onshore and can be set up to allow customer access to monitor their cargo if required. However, most companies still require a visual check of all reefers on board once or twice per day to ensure there are no visual or mechanical concerns. The visual checks are recorded in a log. Checks may increase up to 4 times a day for high-value cargo. Due to the high value of cargo involved in the carriage of reefers, certain safeguards are put in place by the owners to aid the crew if any problems arise. If the ship is many days from the next port and there is an issue with the reefer, personnel will do what they can to keep the reefer running and to stop the cargo from perishing. If the cargo is hard frozen, more time is available to fix the issue due to the container being well insulated. If the ship is near the next port, the reefer can be repaired on shore. Not all reefers are easy to repair by the ship's personnel. However, the owners or operators will ensure that there is always a supply of critical reefer parts on board, aligned to the makes and models carried. Critical spares may include spare refrigerant gas, compressors and oil, circuit boards and electrical parts, spare cables and sockets, evaporator and condenser fans, switches and valves, sensors, and pipes, gaskets, and connections. Due to safety reasons, certain dangerous goods are transported in reefer containers as they can be volatile if not temperature controlled. Examples of this type of dangerous goods cargo are self-reactive substances under Class 4.1 and organic peroxides under Class 5.2. For these reefers, a continuous power supply is imperative at all times, and therefore they will usually have an internal or external genset, which is a piece of portable equipment consisting of an engine and an alternator or electric generator or other means as necessary. There are also some types of dangerous goods cargo which are not volatile, though are carried in reefers for commercial reasons to maintain the product quality, such as perfumes and batteries. Stowage must be aligned to the requirements of the International Maritime Dangerous Goods Code, including the markings, the manifest, segregation from other dangerous goods and reefers, and having the correct firefighting and medical requirements on board. Let's try an activity to check your understanding so far. Drag and drop the correct word or term into each of the blank spaces to complete the following sentence. When you're happy with your answers, select the Submit button. Well done, that's correct. Each reefer will remain on board until the discharge port is reached. The planner or company will confirm if there are any changes to this, as some reefers may be transported to other ports on the shipper's request. Reefers should not be unplugged too soon before unloading, as they may still remain on the ship for some time before. Reefers must not be left too late to unplug on board, as damage may occur to the cables and plugs if the containers are unloaded by the cranes and lifted on shore before unplugging. Therefore, close liaison with the port workers on board is necessary. Well done, you have almost completed this course. You should now be able to give an overview of the regulatory and legislative controls relating to reefer containers. Describe the history of reefer containers. Describe modern reefer containers. Give an overview of reefer container construction and design. Describe the packing arrangement of reefer containers. Explain what information is required for shipping reefer containers. Give an overview of special shipments. Describe the pre-acceptance checks. Explain how reefer containers should be stowed on board. Describe how reefer containers are monitored at sea.